bucka. Haha. You know the deal.
The next thing we're going to talk about in analytic geometry is what's called standard form of an equation. So up to this point, when we've been talking about an equation of a line, we've pretty much talked about one way to write the equation of the line, and that's as y equals mx plus b. And as discussed earlier, that way of writing an equation of a line has a name, and that's called the slope y-intercept form. That was covered in a previous video, but again, the reason it's called slope y-intercept form is because you can look at it and you can see what the slope is, and you can see what the y-intercept is. But we have also seen that there are other ways to write equations. One of the examples we talked about was if we're buying garbage bins and recycle bins, and in that situation it was $4 per recycle bin and $2 per garbage bin, and we had a budget of $1,000. So that is a linear relation. There's two variables there. There's no exponents other than one, no variables in the denominators, and the variables aren't being multiplied together. So that is a linear relation. It's not written as y equals mx plus b, though, and we talked about how to write that as y equals mx plus b so that we could see what the slope and the y-intercept are. Another example of a linear relation is if you have to calculate the perimeter of a rectangle. Well, suppose we knew the perimeter was, say, 100 meters. To calculate the perimeter, we add the length and the length and the width and the width, and we know that we want it to be 100. And if we simplify that, there are some like terms there. L plus L is 2L, and plus W is plus 2W. And again, it equals 100 because I'm saying the perimeter is 100. Now we can't solve W and L here, but it is a linear relation. If we knew what W was, L, we could figure out what L is. And if we plotted those points on a graph, it would make a line. But again here, we can see this equation is not written as y equals mx plus b. So when we're writing an equation of a line in what's called standard form, this is the sort of general way to write standard form of an equation. Ax plus by plus c. Just like y equals mx plus b was the general way to write slope y-intercept form. With slope y-intercept form, we always have a slope and we always have a y-intercept. So we would write it as y equals mx plus b, but there's an m and there's a b. So y equals 3x plus 5 is an example of an equation of a line in slope y-intercept form. Well, just like y equals mx plus b, with ax plus by plus c, a, b, and c are all actual numbers when we have an equation written down. The only difference is they all have to be integers. So we can't have any fractions in standard form of an equation. So a, b, and c are all integers. And another rule of standard form of an equation, so a, b, and c have to be integers. There can't be any fractions in any of those numbers. As well, a has to be a positive integer. So a is not allowed to be negative. It must be positive. So what does all this mean? Well, let's take a look at an example of an equation of a line written in slope y-intercept form. So suppose we had an equation like y equals negative 5x plus 8. So that equation is written in slope y-intercept form. Again, we know the slope is negative 5. We know the y-intercept is positive 8. If we want to write it in standard form, though, you'll notice in standard form all of the terms are on the left side of the equal sign. So that's the first thing we need to do, is make sure all of our terms are on the left side and there's nothing on the right hand side. That's why we have 0 there. So we're going to bring this x term over to the other side of the equal sign, and we're also going to bring this plus 8 over. Now another thing you'll notice in standard form is our x term always comes first, then our y term, and then, if there is one, our number. So because of that, I'm going to move that minus 5x over, and I'm going to put it first. And it does become plus 5x. Because it's the first term, I don't have to write that positive if I don't want to. I could, but I don't have to. Now next we have y. Now I do have to include the sign here, and the sign of y is positive. So I have to include that plus sign with the y. I can't just write y there, because then it looks like I'm multiplying by y. And finally, if we bring that plus 8 over to the left-hand side, it becomes minus 8. Now we still do have our equal sign, and on the right-hand side now, we have nothing. So nothing is just 0. Well, now we've done it. We've taken that equation that was written in slope y-intercept form, and we've written it in standard form. And the reason it's in standard form is because all the terms are on the left side. There are no fractions in any of the terms, and they're all integers, and the coefficient in front of x, the number in front of x, a, is positive. Here our value of a is 5, or positive 5. So if we look back at our sort of general way of writing, for this example, our value of a is 5, because that's the number in front of x. Well, what's our number of b for b? That's our number in front of y, and as we can see here, there is no number in front of y. And when there's no number there, we assume it's a 1. It is plus y, so it's positive 1. And finally, our value for c is just our number value. And we do have to be careful and include the sign here, because it is a negative. So our value of c is negative 8. Let's look at another example where we have to take an equation that's written in slope y-intercept form and put it in standard form. So again, our first step in getting it in standard form is making sure all of our terms are on the left-hand side of the equation. And if we're going to move terms across, we might as well put the x term first, and then the y term, and then the number, because that's how it has to be written in standard form. So if I bring that 3x over to the other side, it has to change signs, so it does become minus 3x. That y, again, there is a positive sign in front of that y, so it's still plus y. And if I bring that minus 2 over, it becomes plus 2. And then once again, now that I've brought everything over to the left-hand side, there's nothing on the right-hand side. Now, this is almost in standard form. There are no fractions here. All the terms are brought to the left side. The only problem here is our value of a. Our value of a is an integer, but it has to be a positive integer. So we're not allowed to have that as negative 3. So we have to change that. We have to make it a positive. And the easiest way to make that into a positive is to multiply it by negative 1. Now, as with any equation, if I do mathematically something to one term, I have to do the same thing to all the terms if I'm multiplying or dividing. So if I multiply one term times negative 1, we have to multiply all of the terms times negative 1 on both sides. So when we multiply negative 1 times negative 3x, it becomes positive 3x. But again, I have to multiply negative 1 times everything. And negative 1 times plus y is minus y. Negative 1 times plus 2 is minus 2. So essentially, you'll notice that just really all of the signs change to their opposite. Now on the right-hand side, 0 times negative 1 is still just 0. So we don't have to change anything on the right-hand side. But again, that number in front of x has to be a positive. So if it is a negative, you have to, essentially what you're doing mathematically is multiplying all of the terms by negative 1. But really, as you see, what ends up happening here is all of the signs end up changing to their opposite. Here's another example where we have to change from slope y-intercept form into standard form. And whatever form we're changing from, if we're putting an equation in standard form, all of the terms have to be brought over to the left-hand side. And we want to put our x term first. So if I bring 3/4 3 over 4x over to the other side, it becomes negative 3 over 4x. That positive y is still positive y. And if I bring plus 2 over, it becomes minus 2. And then I have nothing on the right-hand side, and nothing is 0. Now, we've got a couple of issues here with this in terms of trying to get it into standard form. The first one you'll notice is there are fractions here. So as I stated at the beginning, a, b, and c all have to be integers. They have to be whole numbers. They can't be fractions. And right now our value of a is negative 3 over 4. It is a fraction. So essentially what we have to do here is we have to get rid of the fractions in this question. And we've seen how to do that already a few times. By now we know we need to make a common denominator. I'm not even going to bother making a denominator on the right hand side because it's always going to be 0 no matter what I do to that. Here we can see the common denominator is 4. So the first fraction we don't have to change, but y over 1 we do have to change, and we have to multiply it by 4 to make the denominator 4. If I multiply the denominator by 4, we also have to multiply the numerator by 4. Same thing with minus 2 over 1. Multiply both of those by 4. We get minus 8 over 4. And I could write 0 over 4, but that's still just 0. And as we've seen, now essentially we're multiplying each term times 4. And when we do that, these 4's cancel out. We're multiplying the right side by 4 as well, but it still just stays 0. So what we end up with is minus 3x plus 4y minus 8 equals 0. Now the last thing we have to deal with here is there's a negative sign in front of our value of a. A has to be positive, so we're going to multiply now each term by negative 1, essentially changing the sign of each one, which is keeping the equation the same. It's still the same equation, but just written in a different way. And it's still the same equation as the one that we started with here. These two equations, if you were to graph them on a graphing calculator, would make exactly the same line, because they are exactly the same equation. But the first one here is written in slope y-intercept form, and the second one is written in standard form. So to finish off our lesson on writing equations in standard form, I'm going to ask you to do a few questions here. So for each one of these equations, write them in standard form. A couple of them are written in slope y-intercept form. One of them isn't, but with each one, get all of the terms over to the left. Make sure that the values of a, b, and c, the numbers in front of x and y, and the final number are not fractions, and make sure that the number in front of x is a positive number. If you're able to do that, congratulations, you now have a firm understanding of writing equations in standard form.